with, if this is like a little continuation of 5-1, 5-2, we already did a little bit of this part, and I'll show you the part that it is resembling here. Okay, so we did this fundamental theorem thing where we were looking at turning points and guessing the degree and things like that. Okay, this is what we're picking up on. All right, and I believe I'm trying to look at, so we did a little solving there. Yes, the minimum degrees. I'm just looking to see exactly if we've done it more than once. I know. Which means we'll review both of them. Okay. Got you. All right, so let's do it. Okay, so we're going to review the fundamental theorem of algebra, which just tells us about the degree. We have two statements that tell us about the degree. One of them says that the degree will equal the number of solutions, okay, including multiplicities, okay? We have to add up the multiplicities. The second statement that tells us about the degree, okay, so the degree equals turn point plus 1, because the curvier the graph gets, the higher the degree. So we have two things that tell us about the degree. Yes? Multiplicity is how many times the solution is repeated. Okay? So I will do an example with a multiplicity. Okay, so an example. There are no tick marks on these graphs. They're just axes. That's all these are. And we're going to go like this. Okay. And so we have two statements that tell me about the degree, because that's what I'm trying to figure out here. So I'm going to start by just writing the degree, 1, and I'm going to just write the numbers 1 through 8. Because I don't know what the degree is, but I'm going to assume it's one of these numbers. You could go as high as you want, but I feel like 1 through 8 will give us enough to work with. Okay. And then I'll use two different colors so that you can differentiate what I'm looking at here, because we have the degree, which is equal to the solutions, okay? And then we have the turning point. So we have two things we're going to look at to make our predictions. There we go. That's a much better red marker. Okay. I see one solution because there's one x-intercept. Just one x-intercept. So, real. I see one real solution. Right there. That means that the degree should be 1. Okay? Means can't cross anything out. Okay. Now I'm going to look at the turning points. The turning points. Okay? So I see 1, 2. I see 2 turning points. So if I have 2 turning points, that tells me that the degree should be 3, right? 1 more. All right, so what I want to do is cross off everything that's not going to work. So if this is telling me the degree's got to be 3, I have to cross off those 2 numbers, right? That can't be them. There's one more thing I want to cross off before we get our final answer. Yeah?
What do you mean by +1? Like
That is the formula. So if there's 2 turning points, the degree is 1 more. So the degree would be 3. Okay. There's 1 more set of numbers I want to cross off. No. What's my end behavior? Odd. The end behavior is odd. So let's cross off 4, 6, and 8. Because it's even, or it's an odd degree because of the end behavior. All right, guys. What number is left? The smallest number left. 3. That means 3 is going to be the degree. I mean, it could be 5 or it could be 7, but we're going to go with the smallest one circled. So we're going to say the degree is 3, and I want to know how many real solutions, which is always going to be the same. So that's 1. How many are left over to be imaginary? 2. Because these things have to add up to the degree, because the number of solutions has to equal the degree. Question?
How do you determine that the number is like the lowest?
Because you could, so let's say that, let me make you another box here. What if you wanted to circle 5? Let's just say that you could say the degree is 5, all right? Now, real isn't going to change. It's still 1, okay? So what does that leave for imaginary? 4. We always just pick the minimum possibility.
So even though that happens,
So you do the minimum.
I'm confused by the number of
That's good. Example number 2 is going to have that. Okay, here we go. So let's do another picture. All right, so tick marks are not necessary, just the general shape that I've gotten drawn here. Okay. I'm just going to start with the numbers 1 through 8. And I'm going to do the red and the green. So I'm just going to look reals and turn points. And I'm going to use those 2 pieces of information to figure out what a reasonable degree would be for this graph. Okay. I see 2 x-intercepts. Except that first x-intercept bounces. So that actually counts as 2 solutions. That's the multiplicity. Okay? The appearance of that x-intercept tells you how many times it's repeated. So when I say 2 x-intercepts, that's really accounting for 3 solutions. So when we did our graphing and we were like, oh, this one is squared and this one is cubed, it affected the shape of the graph. And so that's what we're doing here. So hold on. So if the degree has to match this, then I'm crossing out 1 and 2 because it's at least got to be 3. Yeah.
And then if it's like that weird squiggly thing, that's 3.
3, yes.
But this one's straight along the line.
So this one is straight, so that's why it counts as 1. Okay, turning points. Here we go. This is actually a turning point as well. 1, 2. That is not a turning point, guys. A max or a min is a turning point. So I only see 2. Yes.
Wait, so, the one, like above the one where you have the one tally, wouldn't that be a turning point also?
No, that does not change directions.
But, doesn't it because it's straight on a line kind of?
A turning point has to be a max or a min. That sort of pauses for a second, but it doesn't count as a turning point. Okay, so that means that the degree would be 3. Okay, I need to cross off one more piece of information.
Why did you have to 0 equals 3?
Degree equals 3 because it's not 2, it's one more. Yeah.
Still about the question, why is it not a max or min that we look to the time?
Because it's not. No, I know, you're like, oh, that's not an answer. Okay, a max or a min is either the top of a hill, right? Or a bottom of a valley, right? Goes down, goes up. That goes up, pause, up.
Is it because it's like a flat, like?
Yes. A max or a min has to go up and then down,
It has to go like.
or down and then up. This goes up and then up. It doesn't change.
Oh.
It has to change in order to be a max or a min. Okay, so what other numbers am I going to cross off? Yeah, Ram. Yes. All right. It's because my end behavior. All right, here we go. So let's write.
And like an odd one, odd is usually the same direction.
Odd is opposite directions.
Or sorry, even.
Even is the same direction. Yes.
And you tell the arrow direction by it being positive and
Yes.
The odd numbers are in the same direction?
Odds are in opposite directions. 1 second. Okay, so our degree, our real, our imaginary, and I'll put a second box just to show you what could happen. Okay, because, right, 3 is the smallest number. That's what we would answer with, but it's possible. Okay. Real. There are only 3 real. That's what you can see. Imaginary is the thing you can't see. That's what's left over. Now, because of that little squiggle thing here, oh my gosh, those extra turn points give me imaginaries. I feel like this is probably a degree 5 because it doesn't really, it looks too curvy to me, even though I don't technically have enough turning points. It's just a minimum prediction. It's not like a set in stone kind of a thing. It's a prediction. Yes.
So for the multiplicities, you determine them where they hit the x-axis?
Yes. Multiplicities deal with x-intercepts and what the x-intercept looks like. Yes.
Why does the real not have a degree?
Oh, okay. Because it was the same, so I just didn't feel like writing it. All right. Okay. Now we're going to do a little putting some more of it together, and then I'll give you some work time because I can see our eyes are almost glazed. Okay. Putting it all together. Okay, connections. Solve. Graph. Fundamental theorem of algebra. So it's kind of what we just did, except this time I'm going to give you an equation. 2x to the 5th minus 2x cubed equals 0. I want to solve it, I want to graph it, and I want to write down the fundamental theorem of algebra information, which is the degree and thus solutions. Okay, so let's solve by factoring. GCF.
Use the right source.
All right, so I'm going to set each factor to 0. Okay, so in this particular one, I get x equals 0, x equals 1, x equals -1. And as I'm looking at that, do you see how this is cubed? This factor is cubed. That means it's a multiplicity of 3, because it's repeated 3 times. That's what it means algebraically. It's repeated 3 times. Okay, so there's my little graph. And right there's the graph. And I'm going to write down the fundamental theorem of algebra stuff here, okay, which is the degree. Okay, so the degree is 5. This time it's not a guess. It's like it's on the paper. It's a 5. Okay? The number of real solutions is also not a guess because I just solved for them. 1, 2, 3, 4, 5. Because I found them all. Okay? And imaginary. 0. Because I just solved and there weren't any. Right? Putting it all together. The degree tells me opposite arrows. The positive tells me positive slope. So the degree tells me that this is what the arrows should look like. Well, let's put the x-intercepts on the graph. -1, 0, 1. Okay, yes, question.
How do you know the degree's 5? Like, what determines
The highest power.
that? Okay.
Notice that if we look at factored form, we'd have to count up the factors to figure it out, but when it's already in standard form, it's just the highest number.
If it's in factor form, there would just be x minus 1 to the first power and x plus 1 to the second.
If it's in factored form, you would take the leading terms, x cubed, 2x cubed times x times x. Just 2x to the 5th. Okay, here we go. Multiplicity of 3, single, single. So my arrow has to start down and end up. Straight, because it's a single. Okay, I've got to do that, like, point of inflection, that curvy flatten piece. Okay, so flattens, comes down, goes back up. Putting it all together. Solve graph fundamental theorem. Okay, so here's my solving, there's my graphing, and it should all match. Okay, now just to prove to you that like I did it right, I'm gonna pop this open in Desmos and show you that I did do it right. Okay, so here we go. There's my equation. Ooh, no, zoom. back in. Whew. Okay, 2x cubed minus 2x to the fifth minus 2x cubed. There it is. Look at that picture. It's exactly what we drew. Look at that. That's it. 1, 2, 3, 4, 5 solutions. Yes.
And do you know the point of, or the, what's it called, the.
Point of inflection, this curvy thing here.
Do you know the point of inflection is in the middle because the exponent has to be straight?
No, because x equals 0 is the multiplicity of 3, which is the one that has this shape.
Like, what do you mean by x? Oh, you mean like the x is when x equals 0?
Yes.
Oh, okay.
The multiplicity is what gives you the certain shape. Yeah.
You can immediately know if you have a cube in a term, you know it's gonna be that flat and no shape.
Yes. Yes. Okay, here we go. Minus 4x cubed plus 2x squared plus 8x minus 4. Okay, we're going to do the same thing. Solve, graph, fundamental theorem. So you start by solving by factoring, right? There's that 5.3 review. Maybe start with that negative 2 GCF. Try that. Okay, go for it. All right. So x squared, 2x minus 1, minus 2, 2x minus 1. Okay, it's looking good. Okay, I got my factors. Set each factor to 0. Only the factors with an x, by the way.
You also set the negative to be 0.
There is no variable out front, which means that not like you don't get anything. Not applicable.
Like not even 0.
Well, where's the x? You're solving for x, remember?
Oh, okay.
So there's no x, so there's no reason to write that part. Okay, so I
You
got.
get it wrong if you did write it down.
Well, if you wrote this, no, but just, there's no answer that comes from it.
Right, but so like if you added an answer, like if you said
Then
that-
yes, you would be wrong.
So if you said the degree was 3, you'd be wrong.
Well, the degree is 3.
Oh, 4.
Then you would be wrong because the degree is 3. Because it's right there on the paper, okay? Real, imaginary. Okay, so as I'm looking at this, I get x equals 1/2. This is actually 2 answers, right? One of them is negative and one of them is positive. I'm going to zoom back in for you. Okay. So that tells me, now these are all real. The only thing that's imaginary is something with an I. So none of those are imaginary. The degree is 3. Leading term is negative. So that tells me that this is what the arrows are. Yes, question.
Wait, so it's 3 because it's plus or minus?
Yes. Okay, now I'm going to tell you that this root 2 is approximately 1.4, between 1 and 4. Okay, just so I have something I can put on the graph here. 1, 2. So I got one here, one here, one here. So those are my 3 x-intercepts. I got my arrows. None of these things are repeated. They're all just once. Negative 1.4 and positive are different numbers. Okay, so we connect the dots.
or the y-intersection?
Which one?
The y-intersection?
Oh, it's actually -4, right? You could plug that in by plugging in 0 and like calculating it. I didn't label it because I didn't find it, but if you asked, it would come out to be -4.